So, dear students, today another important topic that is linear thermal expansion. On what the factor of linear thermal expansion depends, and we will see the mathematical formula which is used to calculate linear thermal expansion. So here it is. Linear thermal expansion is defined as linear mean length, and expansion mean increase in length. And if you see how it increases with the help of the heat. Therm mean heat. The increase in length of the object after heating is called linear thermal expansion. If a rod is heated, there is a prominent increase in length. The expansion along the length, this is the expansion along the length, or in one dimension is called linear expansion. Suppose this is a metal wire, you heat, it increases in one direction, only one dimension. So that's why it is called linear thermal expansion. So again, repeat. The increase in length of the object after heating is called linear thermal expansion. It is denoted with alpha. It is represented with alpha. And its unit is 1 over K. SI unit of alpha is K, 1 over K. So here it is dependence. If we heat a metal rod, the length of which is much larger than its thickness, then the size in length depends upon the following three factors. Number one, length of the rod, thin rod. Number two, change in temperature. Number three, nature of the material of the rod. These are three factors on which it depends. So here it is. It shows that the length, if the more and more length of the rod is, more it will take to increase its length. Change in temperature means more and more temperature change is there, more possibility of increasing the length of the metallic rod. Third one is nature of the material of the rod, what type the metal is. So if you look at this formula is derived like change in length, that is del L. It is directly proportional to del T. Increase in temperature increases the length. So here it is. If you replace it, that is del L, it is equal to alpha del T. So this will be the mathematical on the basis of more is the temperature increase, more will be the length increase. So this one is the constant of proportionality, which is called coefficient of linear expansion. It is written with alpha. So this alpha is equal to del L divided by L naught. So L naught is basically initial length. If you combine these two, it is basically del L directly proportional to L naught, and it is also directly proportional to T. So here it is. So use highlighter to highlight it. That is del L. It is equal directly proportional to L naught. It is also directly proportional to del T. If you combine these two, that is del L directly proportional to L naught del T. This L is alpha is basically coefficient of linear expansion, and after putting the values, you get coefficient of linear expansion alpha is equal to del L over L naught del T. So this is the formula, mathematical formula to calculate. Now how it was calculated? Let's see the derivation. So here it is. Consider a metal rod of length L naught at a certain temperature T1. Initial temperature is T1. Initial length before heating is L naught. Uh, Sometimes we say that length of the rod at 0 degree and length of the rod at temperature at that is zero, say. And the length L is the final length after heating the temperature T. We have increased the temperature. This one is the length of the rod, and here was the temperature. When we have increased the length, when we have increased the temperature from T naught to T, then the length of the rod increases after heating by the vibration of the atoms. And these atoms are considered like these are the two balls which are connected each other with the spring-like force. And this spring-like force has some types of vibration, and the atoms in the solid vibrate to and fro. And more the heat, more will be the vibration. Less is the heat, less will be the vibration between the two combining atoms. So increase in length is basically del L, and this del L is equal to this one is the L minus L naught, and increase in temperature. We have increased temperature from T to T naught to T. This one we have increased this temperature, and then we have, with the increase of the temperature, the length has increased from L naught to L. So this is the basic technique to understand. So here was the length of the rod. The temperature at that time was T naught. When we have increased this temperature to T, the length of the rod increases because with the increase of the temperature, the vibration of the atoms increases, which results in increase in the size of the length of the rod. So here it is. This is the formula. It is found that the change in length of the solid is directly proportional to its original length, and the change in temperature, which I have already discussed during this. You see, it is directly proportional to the original length. It is directly proportional to the change in temperature. So here it is. So if you look at this one is the same statement. So change in length directly proportional to temperature, and change in length directly proportional to original length. So if you combine these two, you are getting uh, directly proportional to L naught T minus T naught. So you replace this proportionality sign with a constant. This constant is called alpha. It is constant of thermal expansion, coefficient of thermal expansion. And if you put the values, you see this is the same which we follow the increase in length. This is the increase in temperature. You make it simpler. So here L, keep it here. Here it is L naught. Again it is L naught. You can take common L naught from this equation. And after taking common, you are getting L naught, that is 1 plus alpha del T. So this is the increase in length. So here it is. Alpha from equation 1, alpha is equal to L minus L naught, change in length divided by original length into change in temperature. If anybody asks you to define the coefficient of linear expansion, so it is defined as change in length per degree rise in temperature per original length. Change in length per original length per degree rise in temperature. So this is the concept of coefficient of linear expansion. So where alpha is the proportionality constant called coefficient of linear expansion, which depends on nature of the material of the rod and can be defined as it is the frictional increase in the length per unit length per degree per Kelvin rise in temperature. So here it is. Increase in length per unit frictional length per unit per degree rise in temperature. Increase in length, frictional length per unit length per degree per Kelvin rise in temperature. So this is the definition of coefficient of linear expansion. We are defining it with the help of formula. So with this, our today's class ends. I hope you people have understood and you have enjoyed it. Please do